Okay, so now we're looking at problems involving 3D Pythagoras today. So this is going to be harder, but I know that you can do it based on the work done yesterday. So again, we've got our do now questions. So solve means to find that missing letter, or find the unknown, find the variable. Coefficient, that's the number next to a letter. Unknown is a variable or missing letter. An inequality has an inequality sign, and inequality signs are greater than, less than, greater than or equal to, or less than or equal to. I might actually draw them, since that's quite easy. So there is my less than and greater than, and then or equal to's. I'll draw like that. Okay, examples. So this is a bit of a rehash from yesterday. I'm looking for C in this one, and I'm looking for A in this one. So my formulas are as such. We can use this one for this one, and we can use C squared, take away B squared equals A squared. So here we go. We've got 3 squared, which is 9, plus 4 squared, which is 16, equals C squared. So 25 equals C squared. Square root of 25 equals, oh, you just wrote 5 in there, equals C. So C, I've switched it round because we like to have our variable on the left. C equals 5. Okay, here I've got 15 squared, which is 2, 2, 5. Take away 10 squared, which is 100, equals A squared. That leaves me with 125 equals A squared. Now think about what this should be. Closest square number is the square of 11, which is 121. So this is very likely to be 11.1, or maybe even less, like 11.04. So root 121 equals A. A equals, now if it asks for a third form, then we can leave it like that. That's a third, isn't it? Or, and I've written 121, actually 125. Too busy talking about 11 squared. So again, I can't work that on my head because it's quite tricky. So we're going to use a calculator. Root 125, 11.1803 ... So we're going to call that 11.18 to 2dp. Okay, next page. So this is a bit of a recap. Give your answer to 2 decimal places. You can see here we're looking for C, here we're looking for A. Some worded problems as well. So a triangle has the length of these lengths. Is this a right angle triangle? So think about the hypotenuse is the longest side. So here, this is the longest side. So 6.8 squared plus 20.8 squared equals 29.3 squared. If that equation works, you will know if it's a right angle or not. If that equation is not true, then you will know it's not. Find the shaded area. That's kind of easy. I'm not gonna do that for you. Think about area of a triangle. You're going to need that area of a triangle, yeah? And finally, find the perimeter. Okay, so here, find the perimeter. That should be fairly straightforward as well. In fact, that one's pretty easy. So, moving on. This is the crux of today's lesson. How do we find Pythagoras in 3D shapes. Now essentially what we've got here is we've got 2 steps where we were only doing 1. So what do I mean? So looking at my example, find the length of AH running diagonally through this cuboid. So that line there, you're going to have to imagine this is a 3D cuboid. It's going through from H, or at the bottom left, up to A in the top right. So that's actually going backwards through the shape as well. So it's really important that you can see that. Now, what that means is that in order to work that out, we need to find another hypotenuse first. Now, I'm going to use the hypotenuse between F and H, because then that will form me a nice triangle. So this is the line I'm going to find first. We can call that line FH. And then that will give me a nice triangle which I can work from. So this hypotenuse along the bottom here will eventually become a shorter side for the triangle AFH, and that means we can find this hypotenuse. So step 1, find FH or HF. Okay, so to do that, we know that it is going to be 12 squared plus 5 squared equals HF squared. So 144 plus 25 equals HF squared. Yeah, that's going to give me 169. So 169 is a square number. This is a nice Pythagorean triple here, which is when all of the sides are integers. Think of them as like perfect Pythagorean triangles. Okay, so if that is HF squared, I know that this writing is shoddy. I do apologise. Don't forget it's HF as one thing. That means that HF is the square root of 169, which is 13. So now what we've got is we've got this length that I've done in the dots. That's 13. You can label it if you want. So now we know 2 sides for triangle AHF. So I know that the vertical shorter side is 4. We know that the horizontal shorter side is 13, and we need to find the long side. So now we use Pythagoras again. So step 2, find AH. Okay, so we can say that 4 squared plus 13 squared equals AH. I've kind of run out of space, but let's do this really fast. So 13 squared is 169 plus sorry, that's the square of AH, isn't it? Plus 4 squared, which is 16. So that's going to give me 185. So 185 equals AH squared don't forget that should be in brackets, shouldn't it? So we're going to do the root of 185. So AH equals the square root of 185, which is 13.60. To 1 dp we'll call it 13.6, and that'll be cm. I do apologise for running out of space, but hopefully that's quite clear. Find the hypotenuse of one of the flat sides, one of the flat edges, and then use that as the shorter side to find the hypotenuse you're looking for. So you've got lots of work to do here. There's 7 questions, and there's a couple of really hard ones, so I'll maybe go through some more examples in another video. Task 3 is a challenge, so this is where you really got to show me if you're the best. We've done cones before, I know that. There's some volumes thrown in, so cast your mind back to the work we've done before, and then obviously exit ticket.